I work for Canonical, and I work at Canonical, and I am moved to Linaro project. So in this presentation, I will talk about bootstrapping ARM64-bit with OpenEmbedded. A bit of me. I am OpenEmbedded developer since 2004, so it was nearly at the beginning of it. I did some Poki, which is now part of Yocto, in a few years. I am in Linaro since it was created, and for all the time I am there as Canonical secondee. Since 2011 I have a status of Ubuntu developer, but since I started Linaro work I was doing cross compilers in Ubuntu, and it was crazy. I am Debian maintainer for some tools, and I have my blog on which I write about embedded Linux, products, dev boards, different things since 2005. Some people say that I complain mostly there, but check and get your own version of it. So, ARM64. Basically, the question is which name is this, because ARM created this ARM64, which is probably ARM architecture 64-bit, or something like this. Kernel is using ARM64, Debian and Ubuntu, and probably Fedora will also use ARM64 as architecture name. ARMv8 is a version of, is a name of instruction set, which is totally different than the current ARM architecture because there are more registers. They decided to make new architecture. Basically, I feel that it was done mostly from scratch instead of trying to add another set of bits to the current systems. It got new triplet, which is a good thing because it doesn't mean that when you build some software it will see, oh, it's ARM, so let's use this hand-created ARMv5 assembly which will not work. But the problem is we don't have hardware. If everything will be fine, we will have hardware next year from several companies. For now, all we have as people who are doing work outside of ARM, outside of companies, working with ARM, etc. So basically, every open source or not open source developer is free as a beer software model, which is available from this website. There are information about at this in our website you will find information what the fast model is, how to install it, how to get it running. There's also links to OpenEmbedded images and several other information. Basically, it's better to go there and read how it works than just go directly to ARM, because you will go directly to ARM, you will get a binary after registering, which is free. And then you will also have to find it to get to the same place. OpenEmbedded, for most of people, I think that at this conference, I noticed that it's now, this time when I had to tell what OpenEmbedded is, passed. I was really surprised this year when I went to some presentation by someone from the company, which I have no idea who it is. And they were talking about Yocto and Embedded, that they use this, etc. Basically, I wrote this slide, but during this conference, it was like, just waste of time. Everyone knows what OpenEmbedded is. That it's a build system, you can build from small package like Nano, for example, which is basic example. The whole distributions. I was maintaining OpenZaurus distribution, which was built on early years of OpenEmbedded. And at the end, I just officially killed it. It supports wider selection of architectures. You have ARM, you have Super H, you have PPC, MIPS, x86, some crazy things, and now ARMv8. And it uses layers. So, how how did I start? I have to admit that even if I am OpenEmbedded developer since 2004, I had 2 years break from OpenEmbedded when I moved to linear work. So when I fetched OpenEmbedded and looked at it, it was like, brave new world. They have layers. We were discussing this for so many years, and someone finally made it. So for my work, I was using few layers. OpenEmbedded core, as everyone. OpenEmbedded layer to get more software for some tests. Meta-linear layer, which we created some time ago, and it has our SDK and LAMP images, and created own layer for Meta ARM V8 work. At the beginning, on first day, I had to add, as usual, for every new architecture, sub-architecture, some kind of basic support into a few OpenEmbedded classes. Site info has information, what size of, is it 32 or 64-bit architecture, which ID it has in some ELF files, is it little or big endian, basically things which are publicly available in documentation, in Minotaur sources. Insane, the only thing Insane had to add was this arg something is this triplet. And basically, for kernel arg, it's also mapping. ARM64 is arg GNU Linux. Machine definition was easy. I just made a copy of one of ARM7, got rid of all not needed things, and basically just listed. This is generic ARM V8. It is using this kernel and basically nothing more. And architecture tuning files is just a set of flags for linker and CPU. At this time, I decided to not use any of them, but they are here. And during my builds and configuration stuff, I moved the toolchain selection there because for now, with my work, we can use 2 different toolchains, but this will be toolchain. For now, we have 2 versions of toolchains available. We have Linaro GCC for 7. Linaro is working on GCC in a way that they do all development on upstream, on the trunk tree, and then backward it to 4.7. So I took 4.7 release, I took 2012.10 release of Linaro source code. Then I upgraded to version which got several ARM fixes, from ARM. And those fixes were because of work which I did. I catched some internal compiler errors, or some of them were just somewhere around optimizations. And when I was doing those OpenEmbedded work, most of bugs which were found in compilers were fixed by ARM people in a few days. From the book. Binotil strong, public stuff. ELCE, at the beginning I used some private patches because before sending something to public we had to make sure that everything works and that the stuff which we in Linaro had to make was basically creating ELCE port from scratch because of this all legal department of ARM Ltd, which is just huge set of lawyers who don't like to send any patches outside. No-config thing was... No-config is a thing which every new architecture, when you have new architecture, you have to update no-config. And I will tell what problems it gave when we'll get to the point. And when I added first toolchain, the problem was that OpenEmbedded has such list of GCC patches, Some of them are easy to understand, most of them are OpenEmbedded specific, and OpenEmbedded expects most of them to be built, to be applied. If you don't apply, for example, optional libstc++ patch, you will not get toolchain build because of their changes to Bootstrap. And if you don't have all of those patches, probably few, but I didn't have it. I decided to just apply all. You will not build GCC to run on Target. So I started my work in basically at the beginning of September, when I got first version of ELCE patches. It was a crazy build because I was surprised that basically at the start I got 265 source packages built. When I got that ARM with this their cross-compiler work, which Łuki was talking yesterday, they got much smaller size. It's just a difference of doing source-based distribution contra binary-based distribution when you compile everything in their way. And after those builds, I started adding support for fast model. At that time, we only had Virtual Express fast model, the one which requires license, and micro-based image, which is basically just BusyBox plus sysfile init booted fine. At the time, I didn't have the libFFI support, so no new there. In October was great. At the beginning of October, we had ARMv8 Summit in Cambridge, at ARM office and at Linaro offices. So I arrived there on Monday, and when I just entered the Linaro office, guys told me the great news. We have public ELCE patches. We have, at the time, we have had also libf5 patch available, and during that week, we went from 200 packages to 300 packages to about 800 packages built. We got working clamp image, which we used at previous week at UDS to show people that you can run normal server stuff on ARMv8, even if it's slow, fast model, because fast model is just fast just in name. And SDK image was created basically as kind of help to everyone who wants to bootstrap their we build only natively kind of distribution. So, for example, Ubuntu, Debian, Fedora, and whatever. But I spoke with Fedora guys at previous week, and now they are in second step of their bootstrap thing. So I expect them to have something working in a few months, probably similar with Debian will be. And during all those builds, we got into several bugs. Some of them were really interesting. Some of them were typical, were simply bugs because it was just internal compiler error. So I had to provide preprocessed source. And one day I met with Marcus Shawcroft. Sure. And we were talking about those ICs. I presented him all preprocessed files. Next day I got patches which fixed most of them. And after that we got several updates to the compiler. And at that moment I was using ARM backport of all changes to their copy of GCC 4.73 at SVN GCC, which gave me interesting problems during build, because in OpenEmbedded, when you change some component during build, everything which was using it will be rebuilt at next step. So for example, you make update to cross compiler, and then you get the whole image revealed because we have first compiler. And I was using head of ARM3, so there were moments like I came back during the night, my machine was building image. In the morning I saw, okay, I have one small thing to change. I did change, build image 3 hours later. Because someone changed compiler. But building is easy. The worst part is fix all those bugs in software. Because we have this autoconf, right? The German guys have perfect book, die auto tools. But it's not about killing it. And we have autoconf. Autoconf, I will not say that it's great or that it's bad, it just is, right? People hate it. I never met someone who loves it. But it exists. But the problem is that some people likes to edit generated files. So you cannot just run auto-reconf, which will take care also about, in OpenEmbedded, when you have autoconf based software, it will get new config files updated, it will get auto-reconf build, because some macros in OpenEmbedded are changed compared to the normal ones. And when you cannot do it, like for example, in courses, DB, you have to go. But those two were easy because it was just added. I had to add. Please please update new config before you run everything out to come related. And those new config file changes, OpenEmbedded takes care of most of them. Some file, I will not tell the name which software package it was, but had 10 years old code. I wonder how it works in Debian distribution. Probably Debian has a patch for it or something like this. And some parts of software have things that, it is new architecture or new CPU, so I have to break or do something random. And for some of them, it's just one line. For example, Util Linux has huge if architecture is this, those two defines. And it was one moment at Linaro office, I had a patch for it, and I asked Boogie, did he have also to patch it? Yes, I just showed him patch. Do you have a patch like this? Yes, thank you. Because he was not able to put this patch for the ARM legal, right? And for some CPU architecture related definitions, it's easy to just make it work. Some components, like for example S-trace, require work from someone who knows how to do it. I am just building it. I can hack code, but my last application, which had some users, were in previous millennium. Current status of my work, because I'm moving to Canonical in December in public, and most of work is done. It builds. It will be still used because we want to stress compiler. We want to fix to help ARM people to get compiler fixed as much as possible. So now we are working on merging our stuff back into OpenEmbedded and OpenEmbedded core. Most of basic stuff is merged. We still have some patches which are not merged because they were sent to upstream projects and there are no new versions released yet, like libFFI, LTP, not for LTP, no, someone already sent it. But we are going through this. We merged all classes. We merged most of new config related updates. There are few left like Slang or SynLD, but it's a thing to do for me. we are split. We have a split of stuff. Some things which are used are meta-linear layer, like for example, compiler with ARM-V8 fixes. Some are in meta ARM64 layer, like this ARM backward of C47. If someone wants to use the latest and greatest ARM-V8 compiler, then I suggest the compiler for Meta ARM64, but it is not set to any specific revision. It just takes greatest and latest, which can be not nice surprise when someone just updated the compiler and have rebuilt everything. Bill.use trunk and EGLCE patches, libFFI patches are in ARM-V8 layer. I spoke with Ken, and some of parts from ARM-V8 layer, the toolchain parts I will submit to OpenEmbedded code for merging. I hope that it will work. The most interesting thing, how to build it. It's basically I copied it from this how to ARM-V8 OpenEmbedded page. To build everything, I forgot my money. Because you need to copy my layer. There is a script for it in it which will fetch all the needed layers. We'll set up siteconf. We'll set up all the required layers, configuration, toolchain, and then you just need to initiate OpenEmbedded environment and to build that. And description, longer description is on wiki because it also has some information for people who not use an OpenEmbedded and that. So it has how to add package, how to patch it, this kind of things. And I learned from it. OpenEmbedded grown and it is much cleaner than it was. But I didn't thought that adding new architecture to OpenEmbedded will be so easy. During all those years of OpenEmbedded development, we saw people arriving with some new architectures. Some of them were dropped during that time. But it was easy. It was one day of work and there was new architecture work. And yeah, kernel oops is not always failure because I built kernel for fast model and it took me several attempts to get it built and working, and then just when I remember when first time my kernel just booted and told me kernel panic, etc. But I was happy because it finally something which boots. And yeah, and I mentioned that I was in good time. The funny thing was during all this work was when I built Hello World for the first time with this cross compiler. It was like, yes, I am one of those small amount of people outside of ARM which built Hello World for this architecture, and then it was like, yes, I have to wait until those patches will be public before saying someone that I did it. Happens. Questions?
I didn't catch, sorry, you said you're using a emulator or simulator from ARM?
Simulate, yes.
So there's no QEMU yet?
No, there's no QEMU. During that week I heard something about, someone was talking about QEMU, but it is still not yet decided who will make it, etc. So far no QEMU, just a small.
ELCE is Canonical both expressed some interest in doing that work. So it will happen at some point over the next 6 months probably.
The public fast model provides you CPU for serial ports, which are just TCP ports, and virtual I/O storage, and network on USB bus. That's basically all. It is enough to to run software, log into it, have network connection with outside world.
And can you clarify? Did you say that you can get the simulator from ARM?
Yes. You go.
It's on the website. You register for free and download it.
You go to this link.
Yeah.
And there is information about the foundation fast model. You go to ARM, you have to register if you are not yet registered on ARM website, and you just fetch, tarball, unpack, and run. It should run on most of Linux distributions. And from what I know, it's 64-bit. You can emulate quad-core machine, but fast model is single-threaded. So by default, it boots to just one core, and it's the best what you can get. It's the best option. It can simulate, I think, 4 or even more gigabytes of memory. But the kernel which I am using in OpenEmbedded is a bit old and has problems. The problem starts when you use more than 2 gigs of memory. So by default, command line is 2 gigs. If you want to run your kernel in fast model, you have to compile kernel and then merge it with bootstrap, because there is no bootloader at this stage. Bootstrapper is just a small piece of ARM software, but you have kernel command line hard-coded. The paid fast model, Virtual Express, has MMC as storage, and I think they will add also Virtual I/O storage because it's easier to work with, and it has screens on it. But I don't know about license cost.
How does the memory map of ARM-V8 look? Is it also so ad hoc like on the previous ARMs? Is the RAM mapped somewhere at a static place for all different vendors? Or
I will have to boot and just give you the console to play with, because I have no idea.
Okay.
What? Looks like we're done. I will put the presentation on my website, and probably it will also appear somewhere on our website, I think. Basically, it will be. I will write about it on my blog, so it will land on Planet Linaro for sure. Yes.
So we see the 64 bits of ARM is coming into the market, but how about is it going to get to embedded systems? I mean, that's we see more servers, they want to get a 64 bits.
I think that it depends on companies which bought license. I think that at one moment there will be those CPUs will appear also outside of servers. But one of the companies which did something which I saw many times mentioned in recent ARM-V8 news was Airplane Micro, and their server work. Probably there will be something for embedded for mobile, because now this year you can buy mobile devices which have 2 gigs of memory. On ARM, the maximum memory you can get before A15 is 3.5 gig. Calxeda servers have 3.5 gig of memory each one, because you need to have half gig of memory for I/O. Cortex A15 will give you more than 4 gigs of memory because of this large page addressing stuff. And ARM-V8, nowadays it's hard to tell how it will look like, because next year we will have first engineering samples. Today we have fast model, and I heard that some companies got first FPGA implementations, which are slower than fast model, but at least they are cycle accurate. So you can do some toolchain optimization kind of things with seeing that it's really, that my changes is really faster than it was before. Yes?
Talking about support of RPA, what's the main difference between linear toolchain and the backward approaches to the GCC?
Linear toolchain is has fixed RVA changes to one point. Toolchain working group is syncing this RVA work because the goal is to have support of RVA in a linear toolchain. But it's when you take ARM backward, you have the greatest and latest. You have 5 minutes also code needs, right? And when linear toolchain working group has very strict policy of what goes to the tree. So they will, for example, there were several syncs from this ARM V8 tree, and you make a sync, you make merge review, then your code is compiled on ARM V5, V7, x86, 64-bit x86, test suites are run, regressions are tested, and if everything is fine, then it will merge. And it takes something like 2-3 days. So this is why there is a difference. Okay, so I think no questions. Thanks for
Ale przecież to